Hey guys, it's Mr. Mock, ready with your Math 8 Module 4 notes. And we're basically continuing our journey with solving linear systems, okay? And linear systems, if you recall, are when you have two separate equations and you're trying to discover where they connect, okay? So the solution to a linear system is the point where the two lines cross. And as we talked about last week, if they cross, because sometimes they might not, and then they would have no solution. And then sometimes they're the exact same line. You find out, you look at them a little bit closer, and they have the exact same slope, the exact same y-intercept, so therefore they're the exact same line, so they would have infinitely many solutions. But this week, what we're doing is we're solving systems, but we're going to use this method called substitution. And this is how it works. First off, here's a system. I have the first equation is y equals 3x minus 4. And I've already graphed that over here, and it's in the purple line. The negative 4, we start at the origin, we count down because that's the y-intercept. 1, 2, 3, 4. So that's negative 4. And then our slope is 3, which means we go up 3, 1, 2, 3 over 1. 1, 2, 3 over 1, 1, 2, 3 over 1, and we have our line for the purple line there, the top one. The second equation was negative x plus 4, and I graphed that in the red line. The y-intercept is plus 4, so that means from the origin I went up 4, 1, 2, 3, 4, down 1 because it's a negative slope over 1, down 1 over 1, and here it is, our solution, which is over 2, up 2, so 2, 2. Right? So our solution is 2, 2. Now that's if we were to graph it, okay? That's what we had done last week. And so this week we're exploring the substitution method. So what I'm going to do now is I'm going to show you the correct answer, 2, 2. We already know what it is, but I'm going to use what's called the substitution method. So when you look at the two lines, I know that at this point, the point we're looking for, they have the exact same x and they have the exact same y. So for what we're looking for, we want to know, when does y equal y? So let's say I can call this one y1 and call this one y2. When does y1 equal y2? When are the y's going to both be 2? And we substitute by saying, hey, y1 actually means 3x minus 4. So I'm going to take out the y1, and I'm going to say, hey, y1 equals 3x minus 4, so I'm going to say 3x minus 4 equals, and then instead of y2, I know that y2 equals negative x plus 4. And what I've done is I created an equation to solve. So now we just need to solve the equation. Let's use some balancing steps, okay? So in this case, I can add x to both sides, plus x plus x. So then I get 4x minus 4 equals 4. And then I would add 4 to both sides, right? Another balancing step. So that 4x equals 8. And then when I solve this, I would divide both sides by 4, another balancing step. So I've just learned that x equals 2, which guess what, guys? That's what we already knew, x equals 2. But Mr. Mock, I already know what x is. How do I figure out y? Well, we're going to take this and plug it in to either of these equations because I want to know what y equals. So I'm going to pick an equation. I'm going to pick y equals 3x minus 4, and then I'm going to plug in 2 for x. So y equals 3 times 2 minus 4. 3 times 2 is 6. 6 minus 4, guess what, guys, is 2. So we ended up proving our answer using what's called the substitution method. Okay, now I'm going to show you 2 more examples. I really want you to write these down, or if you've printed out these notes and you're just following along, follow along, mark down the steps, really think about what's happening here, because this is a big algebra situation. This is really stuff that you're going to be doing next year as freshmen. You're going to revisit this, but having a good solid base understanding is going to make it perfect for you as a freshman next year, okay? So for number 2, I changed it up and I said, hey, it's not y's this time. I know what the x's are, okay? And I'm not going to graph this, but I know what I'm looking for. I want to know, when are these x's equal to each other? When does that happen? So I have to do 2y plus 3, right? X equals 2y plus 3, so I'm going to replace it. I'm substituting in what it equals to. And I want to know, when does it equal 3y minus 8? What is the solution to this problem, okay? So I see that the 3 here is bigger. I have 3 y's here, 2 y's there. So my balancing step is I'm going to subtract 2. I'm going to get rid of the 2 y's on this side. All right, so balancing step means now I'm going to have 3 over here equals y minus 8. And then I would need to add 8 as my final balancing step. So check it out. I get y equals 11. Now, what do? I know what y equals. I need to know what x equals. And since they're the same, I can pick either. So from this step, pick either equation and plug in y equals 11. Okay, so just for fun, let's just pick this one. We'll pick the top one. So I have x equals 2y plus 3. I want to plug in the y equals 11. So x equals 2 times 11 plus 3. So that x equals 22 plus 3, which is 25. So now I know the point where the 2 lines connect is going to be when x is 25 and y is 11. Those are the 2 points. Because remember, we're looking for where do they cross. And at the point they cross, those x's and y's are the exact same. Okay? Now, this last one is a great one. I love this type of problem. These are really fun, but you have to really put on your algebra hat, okay? So if you want to take a break, hit pause, take some deep breaths, really think about what's going on, and then we'll come back. Okay, we're back. Here we go. In this one, notice how I don't have an x equals and then another x equals, right? I have a whole, I could try to solve for x, but here, this is really where that substitution method comes in, and I really need you to think about this. This equation says that x equals this, 1/2 y minus 3. If x equals that, that means right here, I can replace this x with the 1/2 y minus 3, okay? So you're going to replace the x with 1/2 y minus 3. So check this out. This is what this looks like. I'm going to get 4, and instead of the x, I'm going to put a parenthesis. I'm going to always put in that parenthesis. It really helps. And instead of the x, I'm going to write, because x equals this, I'm going to put in 1/2 y minus 3, and then I'm going to finish it. So I just put this in for x. The rest of the equation is plus y equals 6. Now, distributive property, which means I'm going to do that step there. We've done this already. This is just one of those big equations we've been solving. 4 times 1/2, so 1/2 of 4 means I'm going to have 2y. 4 times -3 is -12. And then I'm going to write the plus y equals 6. All right, combined terms, I have 2 y's and 1 y all on the same side of the equal sign. So that means I have 3 y's minus 12 equals 6. Next, I do a balancing step. Plus 12, because I want to get everything away from the y. So 3y equals 18. And then if 3y equals 18, that means 1y equals 6. Now, I know what y equals. I need to figure out what x equals. And look at that. There's an equation right here that says x equals. And I just need to know y. So I'm going to take y equals 3 and plug it in to x equals 1/2 y minus 3, all right? So x equals 1/2, and instead of the y, it's 6 minus 3, right? 1/2 of 6 minus 3. So x equals 1/2 of 6 is 3 minus 3. So guess what, guys? X equals 0. So that means these two lines right here cross when x is 0, y is 6. All right, team. Those are 3 examples of substitution method. I'll have a little bit of a warm-up on our rotation time. You guys can always, contact me for some Google Hangout Meet, like one-on-one help. I'm here for you guys. Give this your best. There is an Khan Academy assignment to try to wrap up after you watch this video. I hope you're all doing well. Miss you tons. And just keep up the good work. Bye, guys.